Okay, so this is the third lesson for circle theorems. So far we've covered 5 rules, and you should have been sent this link here to complete this Kahoot, just to assess your knowledge. So go and spend 5 or 10 minutes completing that if you haven't, and then of course if you have completed it, you straight into this video. Over to our 6th. There's a few more circle theorem rules to cover. Here's number 6, and it simply states that a tangent and radius meet at a right angle or meet at 90 degrees, the same thing. And you can see the picture here that we've got a radius here and a tangent here, and we've got our 90 degrees marked there. That can be useful because obviously you can form right angled triangles, which might need, you might be able to use Pythagoras, or right angled triangles for SOHCAHTOA. It could be mixed in with those topics. Let's have a look at rule number 7. 2 external tangents to a circle are equal in length. So this line here is the same length as this line. This can be quite useful. I'm just going to put this in a box so you can see it's the rule. This can be useful because, of course, you can form isosceles triangles. So, for instance, if there was a line jotted down here, you can see that we'd have an isosceles triangle on the left-hand side because of the 2 radiuses, but we'd also have an isosceles triangle on the right-hand side. So, again, you can then go back and use more rules previously. So let's have a quick look at an example, and then you can pause it and copy down the rules and even the example into the book as you wish. So this is our example 1. What type of triangle is OPR? So let's follow it around. O, then P, then R. This is an isosceles triangle, and I'm also even going to mark on those 2 lines. So our answer to that is isosceles. So try and spell it right. And work out the value, part B, work out the value of x. So I'm assuming this is x here. Well, to first do that, I'm going to work out these 2 angles, which I know are going to be the same here. So it's going to be 180 minus 130 is going to be 50 degrees, and then I'm going to divide it by 2, so I know that these ones here are 25 degrees. I've got my rule previously that says this is a right angle, and that's that is directly coming from rule number 6, because you can see that we've got a radius, and it's told us that TR, this one here, this line here, is a tangent to the circle. So we know that the radius over here, I can mark R, and the tangent R going up to T meets a right angle here. It's the same on this side, so we know that 90 minus our 25 is going to equal 65 degrees, and that's what x is. Now we know that x is this, we can have a look at the triangle on the right hand side, P, R, and then T, and we know that that is isosceles. So just writing this down, triangle PRT is isosceles, and then we can say that adding up 25 plus 25, and we're going to minus this from 180, and that's going to equal 130 degrees. No, sorry, ignore that. So PRT is isosceles, 180, we're going to 65 plus 65, which gives us 180 minus 130, and that is going to be 50 degrees, and that's our value for y. So you can pause it here and copy down example 1. You can pause it here to make sure you've got rule number 6 and 7 in your book. The tangent radius meet at 90 degrees and your two external tangents are equal in length. And once you've done that, there's an eighth rule. So rule number 8 is a line segment drawn from the centre of a circle to the midpoint of a chord will intersect the chord at right angles. So what that means, if we've got part of a radius here and we've got this chord and M is the midpoint, so that's got to be the midpoint, we're going to form two right angles. So let's have a quick look at a second example. Here we've got that situation on the right hand side. It's said that MB is 12 centimetres in the information here, so I'm just going to label that on there as 12. If M is the midpoint, then we've also got a 12 on this side, and it says the radius of the circle is 13 degrees. So unfortunately they haven't marked on a radius, but that is my cue to mark on a radius and mark that as 13. So any information in the question they haven't marked on, you should instantly mark that onto your diagram always. It says work out the length of MT. So I'm just going to also mark on this as X, so it's really clear just from the diagram what I want to find. So let's see what we can do. We can use Pythagoras to work out this missing length here. So we can do 13 squared minus 12 squared, because we're finding one of the shorter lengths, and we can work out okay, so we need to find out X, and because we know that this length here is 5, and we know that the entire length from O to T, so O to T is 13 centimetres because it's the radius, you can see that we're going to have 13, X is going to be equal to 13 minus 5, which is going to be 8 centimetres, and that is our final answer. Okay, so pause the video now and copy down this example 2 into your book. And then what you can do is you can make a start on the questions. So here are the first 2 questions, so you can pause it now and try these. And try questions 3 and 5. There's no question 4, so pause it now to do that. And for your final question, question 6, and there's an optional challenge, you can pause the video right now and have a go at those ones. Okay, so good luck, and you'll be able to self-mark all of these from the PDF that your teacher will send out.